Testing. Okay, students, let's look at our chapter 11 problems, and we're going to do just a few here. And I'm going to hopefully get a ink color that you can see. So this is chapter 11. So let's look at number 1. Now number 1 says that we have a 0.12 kilogram 50 centimeter long uniform bar. So we got a bar, and the bar has a length of 50 centimeters, which is 0.5 meters. All right, so we got to do that. And the bar has a mass. The mass of the bar, oops, that's going to be in the way. And the mass of the bar is going to be 0.12 kilograms, okay? All right, and it has a small mass glued to its left end, and the small mass down here is, and we'll name these 1, 2, and then we're going to have one right here, 3. And so this mass, the mass of 2, is 0.055 kilograms, and a 0.11 kilogram mass down here. So the mass of 3 is 0.11 kilograms, okay? All right. The two small masses can each be treated as point masses. You want to balance the system horizontally on a fulcrum placed just under the center of gravity. So we're just going to draw a fulcrum, okay? How far from the left end should the fulcrum be placed? So we want to know X, center of mass, number 2. So in other words, where should it be placed? All right, based on number 2. All right, well, we know, if you go back and watch chapter 9 videos, that our center of mass equations is equal to what? Well, it's m of 1 times x of 1 plus m of 2 times x of 2 plus m of 3 times x of 3 all over m1 plus m2 plus m3. Okay? Well, that being said then, it should be pretty easy for us to find where the fulcrum should be placed with reference to the left-hand side, okay, or the left-hand mass. So we'll say the x center of mass based on number 2. So we have to first look at the bar. Now, if we were just to balance the bar on its own, its center of mass would be what? Well, it is 5 meters long and 0.12 kilograms in mass. So the center of mass for that, if it was just by itself, would be what? Well, it would be 0.25 meters because the length of it's 5 meters. So we say then 0.12 kilograms times, we're talking about the bar, okay, times the 0.25 meters, okay, that's the bar, okay, and then we have the mass on the right-hand side, okay, so we got the bar, we got the mass on the right-hand side. Now remember, what are we trying to find? We're trying to find the center of mass with respect to 2, okay, so we have to take then the mass on the far right-hand side, and it's 0.11 kilograms, times, well, it's all the way out here on the end, isn't it? That's all the way out there on the end, so that's going to be 0.5 meters. And then we, of course, put all the 3 masses underneath. So we go 0.12 kilograms plus, and by the way, that mass for number 2 was 0.055 kilograms plus the last one, number 3, 0.11 kilograms. And of course we get an x center of mass of what? It'd be 0.298 meters, okay? And so it would be what? It would be 0.298 meters or 29.8 centimeters to the right of the left hand end of the bar. So in other words, it would be this direction right here, okay? It'd be 29.8 centimeters to the right, okay? That's where the fulcrum would be. So it would be right here. So So we would just say the fulcrum is at 29.8 centimeters. All right? Okay. Okay? Which makes sense if you think about it, because the mass of this, when you say, well, how do you know that's right? Well, all right, let's think about this physically. This mass out here is 0.11 kilograms. This mass over here is 0.055 kilograms. This mass over here is twice as large, okay? It's twice as large. So if you think about it, it makes perfect sense then that the fulcrum should be placed just to the right of the bar's center of mass, okay? All right? Makes sense, okay? Okay, all right. All right, that's number one. So let's go